Thank you so much to the panelists of the coffee panel. We're going to move on now to looking at decarbonizing the built environment. Biochar is sometimes perhaps better known for its soil or agricultural uses, but its use in building materials, composites, and other industrial uses is an exciting way to adapt to climate change while also removing carbon. Our panel moderator, Dr. Harn Wei Kua, has just received the von Klitzing International Engineering Award for his work with biochar concrete and associated LCAs. Harn Wei is also an IBI board member and leads the Smart Materials Laboratory of the Department of the Built Environment at the National University of Singapore, also serving as Vice Dean of the College of Design and Engineering. I'll turn it over now to Harn Wei.
Thank you very much, Wendy Lu, for the very kind introduction. It is indeed a pleasure of mine to be able to be involved in yet another seminar for IBI. And may I have the first slide, please? Okay, today my role is more of a moderator as well as to chair the panel discussion. But the main two speakers will be these two gentlemen over here. All right, first we will have Benjamin Reinke, and of course, next we'll have Gerald Dunst. So they will be able to share with us more on how biochar can be involved in the very significant concept of decarbonizing our built environment. But to kick this off, I would like to start with a very short self-introduction, and of course, to give you a background on how biochar can, and in fact, has been used to make our built environment more sustainable. So may I have the next slide, please? So I'm an associate professor from the Department of the Built Environment in the National University of Singapore. So in the department, I'm leading the group on biochar concrete. And of course, I'm also involved as a trust lead in construction 3D printing, in which we talk about how we can make use of different kinds of concrete, including biochar concrete, to 3D print different structural components. Next slide, please. So how can biochar be used in the built environment? Well, the role of biochar in the built environment is really not just confined to biochar concrete. In the past few years, we have seen so many new ideas emerging, including the use of biochar as a kind of biocomposites, as well as using it as air filter, or even putting biochar in wall plaster and paint. But focusing on biochar concrete, which is an area that I've been working on for the past few years, it is really a very young field. As you can see from my slide on the top left-hand corner, I have this symbol that says 10th anniversary. Indeed, biochar concrete is only 10-year-old. And the first paper on biochar concrete was only published back in 2012. And I only have a few more days left in 2022 to use this particular symbol. And I've been really fortunate to be able to contribute to this ongoing research effort in 7 out of these 10 years. So what have we found in these 7 years, or in these 10 years? Well, for one, we are beginning to have a better understanding of the effects of biochar on the different properties of concrete, including, of course, improving its compressive strength. And we are beginning to see more and more applications of biochar together with other additives such as silica fume, blast furnace slag, and even rice husk ash. Not too long ago, several groups around the world have also started on the use of biochar to improve the resilience of concrete used under harsh conditions, including in marine environment. And one of the newest, latest direction of research in biochar concrete is definitely on the use of biochar to enhance what we call ACC, or accelerated carbonation curing of concrete. And the reason why this is capturing attention around the world is that it is a way of using concrete that is in the process of curing to sequester carbon from the atmosphere, and therefore reducing the net carbon emission of cement. So these are the key milestones that we have achieved in the last 10 years. But there are challenges ahead. And over here, I've highlighted 3 of them. Firstly, there's really a need for us to standardize the kind of biochar that we can use for concrete, both for safety and, of course, for ensuring a high degree of effectiveness. And in fact, IBI is looking seriously into how we can come up with biochar standard for biochar concrete. Secondly, I think we can do a much better job to see how we can make biochar more cost competitive. And I'm not talking about just comparing the price of biochar with the price of cement and sand. For example, if we are going to use biochar in biochar wall plaster, then I think it makes more sense for us to compare the price of biochar plaster with the incumbent materials, the incumbent products. And I think this is one area that really requires a lot of attention in the next few years to come. And last but not least, I can definitely attest to this because I've done some studies on how special kind of biochar can actually give additional functions to concrete when we put a biochar into concrete. For example, we have shown how putting special biochar into concrete can help to enhance the concrete's electromagnetic shielding effectiveness. So it is therefore our responsibility to find out how we can evaluate this additional function, and hopefully that will give biochar concrete, and for that matter, different kinds of biochar building materials, the additional edge in the industry. Next slide, please. So finally, in the past 10 years, we also saw the introduction of 2 new academic journals. So as you can see here, we have biochar and of course carbon research. So any one of you who may be interested in reading up and reading more about not just biochar concrete, but almost any aspect of biochar research, these will be your very good resources. So without further ado, I would like to hand the mic over to Benjamin, and let Benjamin share with us his understanding of how biochar can be applied to the built environment. Thank you. Over to you, Benjamin.
Thank you very much, Harn Wei. I think I'm on. Yes. Hello, everyone. Could you please share my slides? Yes. Thank you very much. So a little introduction to myself. My name is Benjamin Reinke. I'm head of R&D here at Novo in Germany. And we've been looking at the topic of decarbonizing the built environment as well from different angles. And I'm here today to discuss a little bit about our findings, about, so to speak, our knowledge, where we are standing, also with a quick view on our opportunities, but also on our challenges that lie ahead. Next slide, please. All right, so this is short and crispy, a good overview of where we stand. There might be other findings of others that have maybe also tried to reach out to further limits, trying to get more biochar into different applications. But those are the ones where we believe it makes sense to look at. Also stating that this is definitely not those 6 categories aren't the only categories that exist in the built environment. It's just the ones that we are focusing on. And this also sheds light on the fact that it's not always concrete, right? Harn Wei has showed that there's like a lot of information on biochar on concrete. There has a lot been done, but it's not the only part. It is a huge market. It's a huge emitter of CO2. So that's why tackling it makes absolutely sense. But there are just so many more options also to have biochar introduced in the built environment. Starting with asphalt, where you can already achieve great CO2 sequestration volumes with just 2% of biochar added to it. So that's something that makes absolutely sense to follow. Also, and that's I think true for all of the categories, it's that we always want the properties to at least remain good, right? I mean, we don't want to have worse asphalt, for example. We want to have at least the same properties, if not enhanced, like we've just seen, and add new properties or characteristics to it. An interesting field of concrete that's sometimes not really differentiated is precast concrete. It has an addition in a sense that settling time, for example, of the concrete parts might be reduced with biochar, which sometimes for ordinary concrete is not favorable. For precast, it would be, because it gives you shorter cycle times, which means you can produce more parts in the same amount of time. So that's a very interesting fact. We have been able to add up to 10%. And we have absolutely achieved mechanical stability similar to reference concrete parts that have been produced with more or less, so to speak, the same recipe, just leaving out the biochar. So that's that. The classic concrete, we're in that as well, just as we see for a lot of players, especially here in Europe. So that's great to see. Everybody's advancing on that level. We have a collaboration with the University of Luleå in northern Sweden. It's a very fruitful and very great collaboration that we're having there. They have a fire department, and that's talking about enhanced properties. So we're not only looking to get biochar into concrete, we want to see how far can we improve the fire properties so that it will be more durable and resisting fires. Just imagine you have a tunnel where cars are burning. If you can save minutes, if not hours, of this tunnel not collapsing because the concrete is just more robust towards fire. And those properties and all, and in general, mechanical properties are analyzed there in Sweden. And we have already found very good results. Papers are being published, and that's a really great thing to do. Jumping a little bit on the right side, screed or plaster for that matter is very interesting, especially for us, because it's not necessarily statically performing. So that's the easiest way, so to speak, to find a mixture to put it in. Everybody who's following Kathleen Draper knows how it can look like. She's more or less the pilot plan for the world, right? She's more or less doing everything a year or two ahead before everybody else thinks about doing it. And screed is just a great way to encapsulate biochar. Can, if applied properly, help for humidity regulation within a room, and that's great. Also, the color is not that necessary, because usually you always put something on top, either linoleum or rugs or whatever, wood. So if it's a little bit more gray or darkish, that usually isn't a problem. Jumping next to piping, and that's a big one in here. So it's 50% biochar. So we have also been able to create composites, polymer composites with up to 50% biochar. This is obviously 50% is really on the max level, right? So that's quite a lot, and I cannot say that it's heavily altering the characteristics, because it is. It's basically 50% biochar, but it's interesting. It's interesting in a sense that it is common to have polymers with mineralic fillers, and biochar is a hybrid. It's really in between conventional polymers without minerals or mineral fillers in it, and polymers with minerals in it. So it's kind of in between. And this also gives room for applications that are on both sides of, so to speak, the polymer spectrum. And we especially have looked at anti-static behavior, which we were able to show and to prove that with enough biochar, we can have enough anti-static behavior that electronic components, for example, could be stored in boxes. But in this case, we're talking about the built environment. So all the piping, all the plastic parts that are within the built environment, which have also a very interesting sequestration part, because you are usually not digging holes every day. So basically, once you lay out the piping, it will stay there for a couple of decades, if not longer, and they are exchanged. So there's a control on the end of life of this plastic component, which you don't see usually at a lot of different plastic applications, where you lose control of the end of life, which makes it hard looking at sequestration. So that's a very interesting part. And last but not least on my list is insulation. As most of us are aware, with the porosity coming along with biochar, there's good thermal, but also acoustic insulation. And there are different opportunities here. So either included in rock wool, included in insulating boards, but also using it as it is in its, so to speak, purest form as a filling is possible. And we're exploring all of these options right now to see what makes sense. But that's very interesting. Next slide, please. A little bit on the forms of biochar. So there are three what we are looking at Novo Carbo are three different opportunities of using it, so to speak, as an additive in the built environment. I would say that there's a dry possibility, there's a wet possibility. So either it's ground up finely. We have seen that there's not a golden rule. So if we talk to different members of, let's say, different suppliers for concrete, all of them have different ideas on how, for example, particle size should look like. But it's either ground up and used as a powder, or we use coarse biochar to be added, which is dry, and then we have the slurry option where we bring it into a suspension. There are pros and cons of both. For us, primarily, if we look at the dry sector, it is fairly easy to realize if milling and sieving technology is available. And you can always use it for all application, meaning you can always bring it into a slurry. Other way around actually is pretty difficult, also already energy-wise. But there's a big con about it, especially the safety aspect, looking at self-ignition, which comes along with a lot of additional precautions that need to be met, and also the dust aspect. So we have identified quite a few applications where it worked, and it seemed to be very promising, but the amount of dust that has escaped had such a bad effect that there was more or less not a lot of interest to pursue further. So that's something where that's definitely a con. On a wet side of biochar, so to speak, we have seen that it's possible to get finer particles. So wet milling, for example, gives more options than dry milling. And it's especially for the customer or for the ones that are applying it, it's easier to handle. because it's usually working for that process. A big con is that it's not applicable for dry applications. What do I mean by that? It's if your process is not allowed to have any water in it, it's hard, right? How to use it, it's barely impossible. So that's that. And also transportation is an aspect that comes around, because we usually don't want to transport water from A to B. We would like to transport biochar from A to B. And as there's a load limit, that might ultimately lead to the fact that we're actually transporting less biochar than if we would be able to, if we would transport it on a dry matter. So there are pros and cons for both, and we have seen in the built environment, and also for similar applications, all three coming or having a value there, especially if you're thinking about concrete. Next slide, please. All right, jumping right ahead to challenges and opportunities. Starting with the challenges, what we're facing a lot. It's not necessarily the can do, it's more of the allowed to do aspect. So we see with regulations and standards, maybe ASTM or European norming or German norming in this case, biochar is just not considered within many regulatory frameworks. So that's just a fact, and that's hard to tackle, so to speak, within a short time frame, right? So there's the question how to deal with that. A lot of industry players rely heavily on them, saying that after first pilots or trials have been performed, the question about commercialization stands in the room, and this might be a very hard blow to the stomach, because a lot of players don't know how to actually use the material within their framework. Another one, in my opinion, is economies of scale. So the biochar market is fairly young, with lower volumes than those that are competing or that are already existing for decades. I have shown the figure of the European biochar industry market analysis and forecast, where we're standing there. And it shows that we are increasing at a very fabulous rate, but we are far from the amounts that other additives or other materials have, and they come at a way lower cost, mostly also because of it. And that's something that we need to tackle. We are growing. I see pyrolysis units popping out of the earth, feels like everywhere, and that's great, and that's what we need. But we're just not there yet. Proof of concept might be the third one, because we have also experienced that there are architects that would like to use the material. They are interested, but they would like to see that it's proven. They would like to see structures having been built with a lot of biochar in them. And that's something, the hen and egg problem, how to show somebody that it has been done if nobody wants to be the first to do it. So that's a little bit the thing. I've showed a little plant pot. We can show plant pots, but that's not convincing too many to use it in structural buildings. So that's something that's also starting to happen. Really enjoy seeing that, but it just also there. It still takes a little bit of time until we're there. Next one, please. Opportunities. What are the opportunities on our side? We see from an awareness point of view, if we're just looking into our microcosmos at Novo Carbo, a lot of huge media outlets are talking about biochar over the recent half to a year. We have a lot of interest coming out of different areas of the society. So all of a sudden, it seems getting mainstream in Germany, at least. And also the volumes and maturity, as I've already said, we are building a site. We're looking at more sites. We see that as well with all other market players in Europe. It's starting to mature a lot, and that's a huge opportunity. It's just great to see that's kicking off in the right way. And those are the opportunities that we see are necessary, because on the application side, we don't see an issue at all. It works. It's not a question. It's just more how to get awareness and how to be competitive on a market that is fairly conservative, very old, and is not fast moving as we would like it to be. Next slide, please. I think that might have been also already my last one. Yes. Thank you very much. It was a pleasure to talk on this panel. And I'm not sure who am I going to give it to Harn Wei or directly to Gerald Dunst? One of the two.
Thank you, Benjamin.
Thank you.
Thank you. So, let us welcome our next speaker, Gerald. So, Gerald, are you ready?
Hello.
All right. Yours.
Yeah, thank you very much for the opportunity to bring our experience in the area of biochar concrete. Can I get my slides, please? Next slide. I want to introduce myself. We have a composting facility where we produce high quality compost, and out of this compost we produce around 30,000 cubic meter of ready soils. So we don't market compost, we only market ready soils, and we developed 30 different soils. Next slide. Since 2012 we operate one of the first biochar facilities in Europe. It's permitted under the waste regulation, and with this plant we can produce around 200 tons of biochar per year, and our feedstock was grain husks. Next slide, please. We have three reasons why we are sold out of biochar at the moment. The first one is our very fertile terra preta-like soil for producing vegetables in home gardens, filling raised beds, and so on. Next slide. The second reason is our fine substrate for the Stockholm tree planting system. Nearly every city in Austria start with this system, and everyone is very successful. So there will be a big increasing in this material next year. Next slide. And the third reason is our feed jar. We developed different jars for different animals, and they are also welcome to the consumers. So these are three reasons why we are sold out. Next slide. So we decide to build a new biochar facility, which is 10 times bigger. So we will produce 2,000 tons of biochar. The feedstock we will change to screening residues from the composting process. And at the same time, we will produce 3,000 tons of corks, carbon removal certificates, every year. Next slide. And to my opinion, if you go onto the market with these certificates, you should build your facility CO2 neutral. And this means that you have to use as much timber as possible. You have to use CO2 neutral, or at least CO2 reduced concrete. You have to use CO2 neutral asphalt and CO2 neutral energy supply. And after then you calculate all the emitted CO2, and the rest you can compensate. So this is what we do with our new project. Next slide. And now we are come to the challenges when we start with the biochar concrete. The first one is to find the right partner who has maybe some experiences in practice. The second one is to find the right concrete company which is willing to make their own tests and which is willing to use this new stuff. The third one is to find the right building company. This is the easiest challenge. And the fourth one is to to decide which type of concrete are really possible to include this biochar, because there are a lot of different recipes for concretes. And the fifth one is the decision who takes the rest risk. So next slide to the first challenge. We find the company Castor-Con Technologies. It's a new company in Germany, and they have some experiences in practice, and they create the product. It's called Climate Add. With this product, they promise that you can reduce cement and add this product and have the same strengths at the same time. And we thought it's the best to take this knowledge, and so it's not necessary to start from the floor. So we work with this product Climate Add. Next slide. The second point is to find the right company who's willing to do this project with us. We have a very good company near us. It's 10 kilometers from our site, the company Wopfinger. And they start a few months ago to test this new product, Climate Add. And it was really very disappointed, the first test, because it doesn't work. The strength wasn't good enough. And we found the reason, or not we, the company Climate Add found the reason. They had to change the sand. I don't know why. Please don't ask me what's the difference between these sands. They changed the sand, and since this time it works. And we found a mixture. And the recipe at the moment for us is we add 27 kilogram from this Climate Add to 1 cubic meter of concrete. Next slide. The next challenge is, how can you bring this product into the concrete in the company? This is a normal machine, how they mix the concrete. They have different boxes with sand and smaller stones and so on. And all the stuff goes automatically through the mixing machine. Next slide. The mixer you see on the right side has a lot of silos for different amendments. It's not possible to bring this biochar product into these silos. And it's not possible, if you bring it into the silos, it's not possible to get it out. So it doesn't work. So we discuss a lot, how can we bring it into this mixture? And we found a solution. Next slide. We make small bags, and the idea was to add it by hand. So we have 9 kilo bags. It's only necessary to add 3 of these bags into every mixture of 1 cubic meter concrete. We tell it to the workers on this facility and say, what will you really do? We have to add 3 bags per cubic meter. 1 charge is 2 cubic meters, so 6 bags. And you need 4,000 cubic meters of concrete. This means we have to add 12,000 bags into this concrete. No, we will not do it. So next slide, back to the roots. We discuss it again. How can we make it automatically with a special machine which add the product directly on the conveyor belt? But we found a solution, but it would take too long. It would take at minimum half a year to produce this machine and to bring also the software into the right way that it really works. And during this discussion, I have one idea. We are a soil producing company, and our daily business is mixing sand with compost and add different fertilizers to these mixtures. Next slide. And so we decide to mix this product into the sand. This is a pre-mixture with a loader, wheel loader. Next slide. After then, we put it through a screening machine. It's a drum screening machine, which mix and screen it at the same time. Next slide. And we create this, we call it biochar sand or Climate Add sand. Next slide, you can see the different left side, the original, and when you add 27 kilogram of this product, it's a completely black sand. And so the company can use its own technology and use only this black sand for our recipes, and so it works. Next slide. We come to the next challenge. In our project, we have 10 different concretes. It's a different for the foundation, for the bottom floor, for the ores, and so on and so on. And we try to reduce it for our project. We have a lot of discussions with our architects and calculators, and we reduce it to 3 different recipes. And for all these 3 recipes, we found solution to add this product Climate Add. Next slide. When you have done all this work, it works really perfect in practice. So it's completely the same for all the workers. Can you press the next button? It's a video. It should work. I hope it works. No, it doesn't work. And in this way, we make all the walls, all the floors, every concrete is a biochar concrete in our case. Next slide. This is a picture from today. You can see the first floor on the cellar. Also, the walls are produced from biochar concrete. Next one. So all the challenges are done. The last one, the 5th one, was really the biggest discussion. Nobody in this area is willing to take the rest risk. So we took it ourselves. And we hope that everything will work well. But we are relatively sure that it will work because our concrete company with its own lab work very hard on this area to get the right strength from the concrete. Next one. No risk, no fun is one of my points. And at the moment, we are looking for investors who would like to help pushing this technology by buying our pre-corks because we have the best one. Last slide is thank you very much for your attention.
So we are now in the Q&A segment. I'm aware that there are many questions and of course suggestions posted in the general chat board. So let me see, how do you want to do it? Benjamin, I can see that there are a few questions for you on Novo carbon.
Yes. Indeed. I have been starting to answer them while Gerald also talked, because I thought maybe we won't be able to get through all of them in our limited time that we have. So if I go through them very fast, we had a question about the technology readiness level of said materials that I've presented. I said we're like at 4 to 5. So depending on what material we're looking at, but we are in different collaborations with different companies. We are, in that sense, the biochar part, right? We are not manufacturers or sellers of concrete, for example. So that's why we also rely on expertise there from their end, from the material property side of things. So that's that. We're looking at potential pilot projects currently in Europe. That's basically where we're located there, right? So that makes most sense. I was asked what other additives I was talking about if we're looking at comparisons to biochar. Well, first and foremost, we are substituting aggregates and cement. So those are already our competitors in terms of material use and cost. Fairly cheap comparing to us at the moment, but also looking at lime, industrial carbon black, ash as well. So those are usually also found cheaper than our biochar at the moment. Yes. So Kathleen asked me as well if I have found or what I feel are the properties that are most relevant in concrete. My personal perception is porosity particle size is the one that we have seen has a lot of effect. It's in our primary focus. Obviously, we want to have a highest carbon content possible. It wouldn't make sense to have a very low carbon content and have very low carbon sequestration potential there. But we have not yet singled out a particular feedstock. We're located in Germany, so we obviously won't have any exotic feedstocks if we're looking at German norms. So basically, we won't have any coconuts or anything of that sort. We have a lot of wood residue. We have a lot of green cuttings, all of that. We have seen better and worse performance, but also within wood, there's a broad spectrum of it working and it not working. So I wouldn't jump too much on feedstock here. Then Sid has asked, fly ash is traditionally added into cement. If I have seen any studies about using biochar instead of fly ash, that's a little bit. I haven't. I always thought about it as well. I don't know if any of you two have experiences with that. Harn Wei, maybe you? Have you seen something like that?
Yes, I've read a couple of reports and papers using fly ash together with biochar. But I would say that if I'm to draw an average conclusion, the results are mixed. One of the most encouraging results that I've seen is that biochar to complement the properties of fly ash, and for that matter, silica fume as well, when applied to both mortar and concrete. Yeah, so they are definitely not against one another, and they are able to complement one another pretty well.
Okay. Oh,
yeah.
Interesting. And I think the last one that I'm having here from Jackie Smith, if we're partnering with industrial hemp manufacturers adding biochar to hempcrete or panels, we haven't yet. We have already had some contact with hemp. We have pyrolyzed hemp as well, hemp pellets as well. We have had also contact with interested parties that use hemp for a lot of applications, but it's nothing that we have followed in the past. No.
Mm-hmm.
And I think that's all for the questions that I have in my Q&A.
Okay, and there is one question which is more for Gerald, and which is on the rest risk. You mentioned about the rest risk. So what's the rest risk?
Rest risk. It's a direct translation from German. It's there is a little risk because there are no standards and no laws about this new amendment, and no company is willing to take this risk. If you do it outside from standards, there is a rest risk, and you have to take it yourself.
Mm. So in case, for example, a building collapses and you use non-standard concrete, they will ask, well, who the hell had the idea of using non-standardized concrete, right? And somebody needs to raise their hand and say, well, I did, right? But I mean, if you're sure about it, that it works, then yeah, you can take the risk. But that's something where we need to get to, right? So that it's that there are pilots, and that's great to see, Gerald, that once it gets more and more, there won't be the huge risk anymore if it's seen that it works. But somebody needs to start. Somebody needs to take the first leap of faith, so to speak.
Yeah, exactly. Yeah. I'm afraid we have time only for one more question. And perhaps this question by Dr. Isaac Jamison. I would like to direct that to Gerald. Okay, it is about the LEED system, but of course, around the world, we have different kinds of green building standard. All right. So what's your opinion? What does it take for biochar concrete to be included in any country's green building standard or design system? Do you think that this is going to be possible, and what does it take for this to be possible?
I don't know if there is an international standard. I know there is one in Austria, and we try to bring it into this standard next year. This is the way, and I think it has to be done for every single country.
Okay. All right. Thank you very much for all your attention, and I certainly have learned quite a few things from both of you, Benjamin and Gerald. So, and of course, let us not stop all our questions and interaction of this fantastic topic of using biochar to decarbonize the built environment. I think this is an exciting topic. We're not just talking about biochar concrete, but other forms of biochar building materials as well. So I believe you have all our email addresses. Feel free to write to us, right? And keep the communication going. And who knows, we might be able to come up with some collaboration among us. So on this note, I would like to thank the two speakers and all of you for contributing so actively to this track. Thank you very much.
Thank you very much.
Bye-bye.